In this video, we are going to solve the Leetcode problem of the day, and the problem is count the number of powerful integers. The category of the problem is hard, but let me tell you that if you know the maths behind this problem, if you know the logic, the mathematical logic of this problem, this is not even a medium level. This is going to be easy. You just need to know the maths. So first of all, let's talk about what is the given input in this particular problem. So we are given a range, start and finish, both are integers, and we have a limit which is also an integer, and also we are given a string which is s, and that's a kind of suffix. So let me try to explain you using an example. So example number 1, the start is 1, the finish is 6000, the limit is 4, and the given string or the suffix is 124. So one more important thing, so although you are given the s as a string, it is a combination of numbers only. Okay, now let's talk about start and finish. So start and finish means you have a range. If it is 1 and 6000, then you have a range from 1 to 6000, and 1 and 6000 is included. What you need to find out in this problem is the number of powerful integers within this range, and again 1 and 6000 is included. And what are powerful integers? Any integer which is ending with 124 or the given s, and that is why I called it as a suffix. So any integer which is ending with this number or this string is a powerful integer, and you have to tell that what are the number of powerful integers within this range. Now I will come to this limit part, but let's try to find out what are the number of powerful integers we have within this range. So from 1 to 6000 we have 124, 1124, 2124, 3124, 4124, and 5124. So we have total 1, 2, 3, 4, 5, 6 powerful integers within this range. But the output is 5, not 6. And the reason is 5124 is not valid. And this is because of this particular input, which is the limit. The limit is telling us that you can select only those powerful integers in which the digits are not more than the limit. It means that if these are your powerful integers, none of the digits should be more than the limit. So the limit is 4, right? So first one is valid because the digits are 1, 2, 4, and it's within our limit. 4 is included, okay? 1124 is valid, 2124 is valid, 3124 is valid, and 4124 is valid as well, because all the digits in this particular numbers are within our limit. But in case of 5124, there is a digit which is 5, and that's more than the limit, right? And that's why this is not valid for our scenario. And that is why the total number of powerful integers from 1 to 6000 are 5. 1, 2, 3, 4, and 5. Now imagine if this start is not 1, but this is 1000. So in this case, the output is going to be 4, and that's because this number 1 to 4, that's outside of our range, right? Our range is 1000 to 6000, and 1 to 4 is outside of it. So we need to take care of this range, this suffix, and the limit as well. Let's try to understand this with one more example. If the input is start is 1000, the finish is 2000. So you have a range 1000 to 2000, right? You have a limit that your integers or your powerful integers will not have any digit more than this given limit, which is 4. And the ending of all the powerful integers should be 3000. But you can see that the ending itself, the suffix itself, is more than the limit, right? It's outside of our range. So in this case, we can directly say the output is 0. There is one more important information which is given in the question, and that is the suffix will always be valid. All the digits which are in your suffix, that is going to be within the limit. Okay, so if the limit is 4, you will not get a suffix like 1, 2, and 5, because 5 is more than the limit. It can be outside of your range, but the digits are never going to be more than the limit. So that's all the information we have. So one of the process to solve this can be, you can run a loop from 1 to 6000. I'm talking about example number 1, and then you can check for each number within this range. For example, you can check for 1124. You can convert it to a string, and then you can check that the last 3 characters has to be your suffix, and the first character, the remaining character, none of the digits should be more than your limit. That is one of the way you can solve it. But the problem with this particular approach is, this is a brute force solution, and the problem is hard level. The constraints given are too large, and so brute force is not going to work. The logic is going to be okay, but it is going to give you time limit exceeded error. So we are not going with this, and we don't need to go with this. Remember, I told you in the start that you just need to know the maths behind this problem. And let's talk about the maths behind this. And we are going to understand the maths with this particular example. Let us say you have a start as 100 and the finish as 53521. The given limit is 5. It means all the powerful integers within this particular range, none of the digits are going to be more than 5. S is 23. It means all the integers are going to end with 23. For example, it can be 123 or 3223, right? But it will not be 3623, because we have 6 as a digit, which is more than the limit. Now let's try to break it down pieces by pieces and try to understand it step by step. For now, you can forget about this start, okay? Don't try to calculate from 100 to the finish, that is 53521. and I will tell you the reason behind this. Let's try to calculate it from the beginning, from 1 to the given finish number, which is 53521 for this scenario. And for your given number, the last two digits, they are fixed, right? They should be 23, right? Then only we can calculate them as a powerful integer. So the last two are fixed as 23. So let us say you have this number, right? Where the first three numbers or the first three digits are not filled. We will try to fill it, and the last two digits are fixed. That is your S, that is your suffix, right? We need to count all such numbers which are ending with 23, and these three characters or these three digits could be filled with the valid values. We need to find all the combinations, right? Now let us try to find out the combinations for each of the given digits. What are the different valid values? So we can assign them a index 0, 1 and 2. So these are your prefix and this is your suffix. So the prefix are having the indexes as 0, 1 and 2. We are going to run our loop for 3 times, for index 0, for index 1 and for index 2. So let's try to run it for index 0. When the index is 0, what we are going to do is, we are going to check how many digits can you fill at this place, at the 0th index. So what is our limit? Our limit is 5, right? So we can only fill the numbers 0, 1, 2, 3, 4 and 5, right? These are the 6 numbers which are possible, which we can fill at this place, right? But we will only fill it with 5 numbers, that is 0, 1, 2, 3, 4. Only these 5 numbers will be filled at this place for the first loop. And the reason for this is, the number itself which we have in our range or in the finish, that is going to be our last number, is 5. So we are not going to check by putting 5 at this particular index or this particular place in the first loop. Because if we put it as 5 and let's say we put the second as 3 and the third number as 5 itself, but this is outside of our finish, right? This is outside of our range. So you can understand this with this maths, that if we put 5 here, we are actually taking the maximum numbers which are possible, right? But instead of 5, if we put it 4, right, the maximum number behind 5, then even if we put it 9 and 9 here, this number is going to be less than the finish. I know that this 9 is outside of our limit, but let's imagine that we have a number 49923. This is going to be less than our range, right? So we have to be within our range. So we are not putting 5 over here. In the first loop or in the first iteration, we are only putting it till 4. So if the number is 5, we are taking it till 4. Only if it is within the limit. If this digit itself is outside of the limit, then we will have a separate logic which I will show you. For now, I have taken all the 3 numbers which are our prefix within the limit. So if the first number is 5, we are only going to go from 0 to 4. Okay. So the first index or the first digit can have total 5 combinations. Okay. So this is 5. What about the second and the third digit? And now again, I'm telling you one important thing which you will understand now, that if you are taking this as 5, you will still need to have a limit here, right? You will have to limit your numbers here. But if you are taking it as 4, you don't have a limit. You can take all the possible numbers, right? If 9 is a possible number, you can take 9 as well, right? Because anyhow, your number is not going to be outside of your given finish range. And that's why we are taking it from 0 to 4. This is allowing the second and the third index or the second and the third digit to be from 0 to 5, from 0 to 5. That is, we can take all the numbers which are within our limit. In the first loop, what we are going to do is, we are going to check for the index number 0 and we are going to check how many digits can be allotted here. So if the number is 5, we can allot 5 digits from 0 to 4. For other two numbers, we will check from the limit, that if the limit is 5, we can assign total 6 numbers, because 0, 1, 2, 3, 4 and 5. These are total 6 numbers. So at the index number 0, it is going to be 5. At the index number 2, at the index number 3, this is going to be 6 and 6. These are the number of digits which we can take for each of the digits we have. So 5 at the first index, 6 at the second and 6 at the third. 5 multiplied by 6 multiplied by 6, this is going to be 180. So we got the count as 180 when the index is 0. What about when the index is 1? When the index is 1, we are going to fix the first number as 5. And now we are going to calculate the number which is going to start from 5, and then we are going to fill few valid values, and the last two are going to be 23. Okay, let's do it again. If this is 5, this is 23, and now we are trying to put at the index number 1, then what are the valid values at this particular place and at this particular place? For this, we have just 3 valid values, 0, 1 and 2, because the number itself is 3. So we are not going outside of it. We will not be going outside of it, and we are going to say 0, 1 and 2 are valid values. So we have total 3 numbers which are possible at this place. And again, for this, we have all the 6 numbers from 0 to 5. That's our limit. So we have 3 numbers for the first place, 6 number for the second place. We are going to say 3 into 6 is equal to 18. So now we have another information, that if we fix the first character as 5, then we have total 18 combination at this place when the last number is fixed as 23. So we already had an answer as 180. Now we have another answer as 18, right? So 18 plus 180 is going to be 198. So as of now, our count is 198. Let us try to do the same thing with this particular index. So we can say that At index number 2, 5 and 3 is fixed. The last two are going to be 23. 5 and 3 is our starting two numbers. 2 and 3 is going to be our ending two numbers because the suffix has to be 23. So in this case, this is 5 and 3, this is 2 and 3. What is the range for this number? Our given number at this place is 5. So we can go from 0 to 4. So we will go from 0 to 4. That's total of 5 numbers, right? So we have 5 more numbers. And then we have 5 plus 198. We have total 203 numbers. And what is this 203? These are total number of powerful integers you have from 1 to 5, 3, 5 to 1. That's your range. Okay. Now you might have a question that what about these two numbers? Are we having any calculation for these two as well? We will have it. I will tell you why. See, our number is 5, 3, 5, 2, 1. What is the maximum we are calculating as of now? We are calculating till 5, 3 and till 4. So 5, 3, 4, 2, 3. That's the maximum range we are calculating. Okay. From 5, 3, 4, 2, 3 and 5, 3, 5, 2, 1. We can have one more number if this last number we have in our original number or in the original range is more than the suffix. What I mean to say is if this is 21, then 203, that's our calculation, is final. But if it is 24, then in this case we can say that we have one more number 53523 which is valid. We are only calculating till 53424, right? If the number is 53524, we also need to find in the next range, and that's one more if the given suffix is less than the original number we have in the last two digits. This might sound confusing, but what you can do is you can try to find, or you can try to do the same thing with different combinations of input, and then everything will be clear to you. So right now 21 is not more than 23, so we have 203 as our total number of powerful integers. But remember guys, we were going from 1 to our given range, and we have to go from 100 to our given range because 100 is our starting point. And now why I was not starting from 100, because using this method it is very hard to find out when is our calculation going to be more than 100 or less than 100. So this comparison is going to be very hard. So instead of that, we are calculating from 1 to our given finish range, and then we will calculate from 1 to start minus 1. Why start minus 1? This is because we are including the start in this first answer only, because start is included. So we are going to calculate from 1 to 99 because start is 100, and we already have a calculation for 1 to 5, 3, 5 to 1. So we can just take the difference of both the answers, and that is going to be our output. This is not going to be our final output. Okay, we have to do one more calculation. 1 to start minus 1. Start minus 1 is 99. Now 99 has two characters. Our given suffix has two characters. So we know that the maximum number of powerful integers we can have is 1. And when we will have 1, if the number we have is more than the suffix. So if 99 is more than 23, which is our suffix, then we will calculate it as 1. Otherwise, if the suffix itself, or if the starting point itself was 22, let's say. So if the starting point is 22, so from 1 to 21, we will have no powerful integers ending with 23, right? So right now we have 99, so we have total one powerful integer, and we can just say calculate the powerful integer for our given input, the finish range, calculate it for the start minus 1 range, take the difference. 203 minus 1 is going to be 202, and that is going to be our final output or final answer. Now how are we going to implement this mathematically? Let me tell you. For each of the index, we just need to know what is our current number. So our current number is 5, which is within our limit. If it is within our limit, we can just say our current number multiplied by what is our limit, 5. So we will say our limit plus 1, that is 5 multiplied by our limit plus 1 to the power 2 or to the power 1 or 0. And how are we going to calculate how much power we need to give? See, we need to go till 2, right? So in this case, we will have 2 powers left if we are starting from 0. So 2 minus 0. If we are at index number 1, so we have to give 1 power to 6. 6 to the power 1 because the index is ending at 2 and starting at 1. So 2 minus 1. At this particular index, you have 5 multiplied by 6 to the power 0. That is 5 multiplied by 1. This is because we are at index number 2 and our limit is at index number 2. So 2 minus 2 is 0. This is how we are going to do it mathematically. Now let me show you one more example which is very important to know. Now let's say all the input are same. Only the finish range now is 6, 5, 5, 2, 1. Okay. In this case, again the last two characters are fixed as 23. The first three characters are something we need to fix, right? We need to fill. What are the possible values for each character? But the moment we see that the first value which we have in our range, that's more than the limit, because 6 is more than 5. 5 is our limit. So from here we can conclude that for all these digits, we have all the options from 0 to 5, 0 to 5 and 0 to 5. Because even if you take the maximum value which is 5, 5, 5, that is 5, 5 and 5 and then 2, 3. This is going to be within your finish range, right? Because your finish range has a limit, has a number which is more than the limit. And in this case, the moment we find that current number which we have in our loop is going to be 0, 1, 2, right? Because last two are fixed. So anytime we found that we are at a number which is more than the limit, we can just directly say that How many numbers are we left with? So we are left with 3 numbers. So we can say 6 is to power 3. 6 is coming from the limit. Limit is 5. So total 6 combination we have 0, 1, 2, 3, 4, 5. So 6 into 6 into 6, that is going to be 216. And then we will calculate how many we have before 100. So we had 1. So 216 minus 1 is going to be 215, and that is your answer. So I think that's the maths behind this problem. Again, this might seem a bit confusing or a bit complex. So what you might need to do is you might need to just create few combinations of input by yourself and try to fit the same information which you have as of now, the same knowledge which you got from this video. Try to fit it there, try to fit it into your own input, then you will gain some more knowledge on it. So now that we know the logic, we can go back to our code editor and try to solve it using Python. So first of all, let us create a function which will do the calculation till a particular range. So def calculate or cal, and then give some input. X is going to be our range, s is the suffix, and limit is also something we will pass. And then we will find out how many powerful integers we have from 1 to x. And in return, what we can say, we just need to return the calculation of till finish for s and limit, minus calculation of start minus 1, that's another range, and s and limit is going to be same. So now we just need to implement the cal function. First of all, we are going to check if the length of our given range, if it is less than the given s, in that case we are going to return 0, because if the given suffix is more than the range, we will not have any powerful integers, right? Also, since we are checking the length of our range, we need to pass it as a string. So str of our finish and str of start minus 1. Next is you need to check if the length of our range, if it is equal to the length of our suffix. It means maximum we can have is one powerful integer. So we need to return 0 if x is less than s, right? But if it is more than s, then we will have one powerful integer, right? So else 1. So these are the base cases. Now let's try to calculate it for other cases. So count, that is going to be 0 for now. Then let us find out how many prefix we have, how many digits we have as a prefix. So we can say p length, that is prefix length, that is going to be equal to length of the given range minus the length of our given suffix. And since our suffix is fixed, let's try to find out what it is. So suffix is going to be equal to x, and now we can take some part of the string which is starting from plen, that is after the prefix we have all the numbers as suffix. So we got our suffix. Now let's run a loop for I in the range till p len, that is the prefix length. Then first of all, we are going to check if the integer of x of I, we are converting it to integer because we have passed it as a string. So if the current number itself, if that is more than the limit, the moment we got it more than the limit, we can directly say count is equal to count plus limit plus 1, and then we are going to take power. And what is the power value? That is going to be how many digits we have left now. So p len minus the current index of loop, and then we can directly return the count. We don't need to calculate anymore. And what if this condition is not true? For example, if the limit is 5 and the current number itself is 5 or 3, in that case we are going to say count is equal to count plus, then we are going to take the advantage of what is our current number, it is x of I, and then we can multiply it with limit plus 1, and we need to power it up with how many indexes we have more. So p len minus I minus 1 as well, because this minus 1 is because we are utilizing one of the index and putting it as our current number. Okay, now after the calculation we need to check one more thing. If my suffix value in the range is more than or equal to the given input s, in that case we need to say count is equal to count plus 1, and that's it guys. We just need to return the value of the count, and that's the complete code for this particular problem. Let me show you the complete code first. So this is the complete code, right? And now you just need to submit this code, and you will see that this is a pretty efficient solution for this particular problem. All the test cases are going to be passed. So yes, you can see all the test cases are passed. Runtime is pretty good, memory used is pretty good. So this is a good solution for this particular problem. And that's it for this video as well guys. And I hope that this video did provided you some help regarding this problem, regarding the kind of problem you have, regarding the problem description, the approach to solve this problem, and the code itself. So if you like the video, then make sure that you hit that like button, and if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well, and I will see you guys in the next video. Thank you for watching this video guys.